be discussing the application of life cycle assessment and data applications for monitoring and evaluating environmental key performance indicators of road maintenance and rehabilitation. The overall aim of our ongoing project CIRCOM, which was initiated by the Conference of European Directors of Roads, has been to enable the incorporation of resource efficiency and principles of circular economy into future decision-making by national road authorities within the EU. Life cycle assessment has been incorporated into the risk-based assessment framework as a methodology that assesses the environmental impacts of a product or system throughout multiple life cycles, subsequently assessing key performance areas such as risks to climate change, resource efficiency, and biodiversity. The methodology includes 4 primary steps. Firstly, defining the goal and scope, which includes defining a functional unit for what you'll be assessing, as well as scoping the system boundaries for everything that will be included as well as excluded from your assessment. Secondly, all data which will be required as part of the assessment is mapped, collected, and aggregated into an inventory. Thirdly, this data is then used in the modeling of the maintenance scenarios defined as part of your functional unit. Fourthly, once the scenarios have been modeled, results can be produced from an impact assessment and then interpreted. These results include impact categories such as climate change, quantified as kilograms CO2 equivalent, or freshwater eutrophication and freshwater acidification, as well as the depletion of minerals and metal resources, among others. The results will indicate how the flows of resources and materials incurred by the system contribute to the sum of environmental impacts categories. This is also known as a hotspot analysis. In order to assess the validity of one's results, a sensitivity analysis of how the environmental performance of a system changes in response to varying parameters, such as, for example, measuring the response of the climate change results to adjusting the recycled content of utilized materials. This approach can highlight parameters to be assessed for uncertainty, which may lead to further iterative applications of LCA to improve the certainty of the results before it can be appropriately considered in supporting decision-making with respect to the tendering of contracts for road maintenance. To illustrate, let's look at the complete life cycle of an asphalt road. It begins with the upstream supply chain of material extraction, followed by the production of semi-finished goods, such as asphalt production, followed by road construction, which is then followed by the road's use and maintenance. The end-of-life stage in this figure here is crossed out to emphasize the project's aim of increasing resource efficiency and circularity via the transition towards indefinite road maintenance and rehabilitation, thus preventing the degradation of the road to the point where complete reconstruction of the road is required. Presented here is a framework for assessing and benchmarking environmental impacts of road maintenance for integration as risks in the risk-based assessment framework. A complete maintenance strategy is composed of maintenance activities and corresponding end-of-life activities for the residuals generated during maintenance. Each maintenance activity will require data on specifications pertaining to material sourcing, processing, and transport. End-of-life activities corresponding to each maintenance activity will require data on the same components with the addition of specifications on the recovery of resources. Each strategy will also require data on the initial road specifications, such as the dimensions and traffic loadings, as well as the period for which maintenance of the road will be assessed. The results derived from the LCA are benchmarked against KPIs of traditional and alternative maintenance techniques before being further integrated into the risk-based assessment framework. The validity of an LCA is highly dependent on the availability and quality of data. A maturity rubric was established to assess the degree to which all required data is available, as well as the quality of the data which is available. This includes primary foreground data from suppliers maintenance contractors, and NRAs, which specifies the flows of materials and resources associated with a maintenance activity. Background databases like GABI and EcoInvent databases are also utilized, which quantify the impacts resulting from the flows of materials and resources as specified by the foreground data. Within LCA, data quality is generally assessed according to how representative the data is of the assessed system, according to geographic, time, and technological relevance. As you can see here, stages 0 to 3 of the rubric describes a level of maturity where a partial data inventory is available, with data which poorly represents the geography, time, and technology used by the assessed scenario. Stages 4 to 6 describes an accessible data inventory which can represent the majority of materials and resources, as well as tracking of the resulting KPIs, as well as preliminary development of KPIs tracking resource efficiency and circularity. Most data covers a period of time no older than 5 years and geographically accurate to the nearest region. At this stage of maturity, issues regarding transparency are also addressed through accompanying metadata accurately describing the quality of each data point in the inventory, thus increasing the awareness of performance. Stages 7 to 9 describes the state of data availability and quality, where all data has been harmonized under the same standards and formats and are centrally stored and maintained on an online platform through a comprehensive data management system wherefrom data can easily be accessed by all relevant stakeholders. All published assessments have received third-party verification, and NRAs are transparent about their progress towards unambiguously defined targets. Evaluation of data availability and quality was performed by the NRAs and contractors within the consortium of the project. The responses by the NRAs reveal a relatively low to moderate score for both the availability and quality of data. A lack of quality data incurs a heightened uncertainty in the validity of results generated by the LCA model. A high level of both data quality and availability from the contractors, however, shows that they are typically ready to provide data for this risk-based assessment framework. The numbers correlate with the general trend of product LCAs being required for tendering. The disparity of scores between the contractors and the NRAs highlights the need for building and improving digital infrastructure for connecting and incorporating data from industry into centralized asset management systems. Low quality data introduces uncertainty to the results. However, this is not inherently a problem as long as the sensitivity of the final results is also low in response to incremental changes to that specific data point. Data representing flows which heavily influence the end results require a much higher degree of certainty for the assessment to remain valid. Part of the project, we have selected a range of KPIs under categories, as you can see here, such as performance, cost, resource efficiency, circular economy, environmental, and social. These KPIs have been integrated into the risk-based assessment framework, helping us measure and evaluate the performance of our road maintenance and rehabilitation strategies. Thank you for your time today. We believe that through the application of LCA and data applications, we can effectively integrate resource efficiency and circular economy through monitoring and evaluating environmental KPIs of road maintenance and rehabilitation. You can find us on LinkedIn and Twitter to follow the CIRCOM initiative as we continue to develop and refine our risk-based assessment framework for incorporating resource efficiency and circular economy into road maintenance decisions. You can also find us at our website, circom.project.cedr, where the project's reports are published.